For months, Voyager 1, humanity's farthest spacecraft, stopped talking. NASA feared its greatest mission was over. Then, against all odds, a faint signal returned. But what it carried wasn't what anyone expected. Was this a simple fix, or did something out there wake Voyager up? What happened next didn't just restore contact, it may have saved NASA's most legendary mission. Let's dive right in. When NASA lost contact with Voyager 1, silence filled the control room. For decades, this tiny spacecraft had whispered to Earth from beyond the solar system, a faint heartbeat traveling more than 15 billion miles through the darkness. Then suddenly that heartbeat stopped. At first, no one wanted to believe it. Voyager 1 wasn't just a machine, it was humanity's oldest explorer. The farthest reach of our hands into the unknown. When it went quiet, it felt like a piece of us had disappeared with it. But behind that silence, something unusual was happening. The signals that had once carried clear scientific data started to arrive in strange, precise patterns. Not random static, but structured noise. It was too clean to dismiss as chaos. Engineers thought it might be a software glitch, maybe a hardware failure. Yet deep down, a question hung in the air. What if this isn't a malfunction, but a message from something out there? Voyager 1 was built in the 1970s, its computer memory smaller than the image file of a single smartphone photo. And now, in late 2023, that ancient hardware had to survive cosmic radiation, cold, and isolation beyond the sun's protection. NASA engineers soon pinpointed the problem. The spacecraft's flight data subsystem, its brain, had developed a corrupted section of memory. Just 3% of it was damaged, but it was enough to stop Voyager from sending any readable data back home. It was like trying to fix a typewriter that's floating 15 billion miles away. No physical repair, no access. Every command took 22 hours to arrive, and another 22 hours for the response. Every attempt was a 2-day gamble. And yet the team refused to give up. They studied the original design documents, pages scanned from yellowed binders written half a century ago. Then they crafted a plan that seemed almost impossible. To move critical code away from the damaged chip, rewriting Voyager's operating system remotely, by hand. For days, the engineers worked line by line, reprogramming a spacecraft that hadn't been designed to be reprogrammed. They divided the code into fragments and tucked them into surviving memory banks, adjusting every pointer and reference manually. It was a quiet act of human defiance. Not just against failure, but against time itself. On April 20th, 2024, a faint whisper reached Earth. Voyager 1 was alive. The first decoded signals didn't make sense. Voltage readings shifted, plasma densities fluctuated, and magnetic fields pulsed in perfect rhythm, as if something around the spacecraft was resonating. NASA scientists double-checked the data, assuming it was an artifact of corrupted code. But the patterns were consistent. They weren't random noise. Something in the interstellar medium, the thin plasma between stars, was changing. What Voyager detected could have been the signature of a dense boundary, a ripple in the interstellar plasma, or even the distant echo of a cosmic shock wave. NASA didn't claim it was alien or supernatural, but one fact was clear. Voyager had found something new, something our instruments on Earth had never recorded. And just like that, humanity had a reason to listen again. Restoring contact was only the beginning. Now came the harder part, bringing Voyager's scientific instruments back to life. For months, the team sent careful, patient commands, one at a time. 2 of the 4 instruments came online first, the magnetometer and the plasma wave subsystem. They began transmitting again, picking up faint hums from the deep beyond. When NASA converted the plasma data into audio, what they heard wasn't silence. It was a soft, continuous vibration, the sound of charged particles brushing against the spacecraft. One scientist described it as the universe breathing. Every hum, every pulse told a story. The region around Voyager wasn't empty. It was alive with gentle motion, waves of plasma, faint echoes of supernovae long gone, ripples from the galactic wind. But Voyager's age was catching up. Its thrusters, tiny engines that keep the antenna pointed at Earth, were fading after decades of use. Without them, even a slight drift could end all communication forever. So NASA made a desperate decision to reactivate backup thrusters that hadn't been used since 2004. No one knew if they'd still work. On March 20th, 2025, the answer arrived. The backup heaters came online, pressure stabilized, and the engines responded. Against all odds, Voyager corrected its aim and sent a clean signal home. It was the spacecraft equivalent of a 90-year-old astronaut waking up from a coma and standing tall once more. Even with this miracle recovery, Voyager's clock is ticking. Its power source, a trio of nuclear batteries called radioisotope thermoelectric generators, loses a few watts every year. That means less electricity for heaters, instruments, and the transmitter. Sometime in the 2030s, the energy will run too low to keep anything running. When that day comes, Voyager will drift silently into the dark, carrying with it the last voice of our solar system. But the irony is beautiful. A probe built to last just 4 years has become our longest-running ambassador to the stars. It's not just sending numbers, it's rewriting our understanding of space itself. From Voyager's data, scientists discovered that the plasma outside the heliosphere is 40 times denser than expected. They found magnetic fields beyond the sun's influence to be more stable and aligned in strange, unexpected ways. And they realized that interstellar space isn't silent, it hums with energy. Voyager didn't just travel into the unknown. It revealed that the unknown isn't empty. It's alive. But beyond the data, beyond the science, there's something profoundly human about this mission. Strapped to Voyager's side is the Golden Record, a message from Earth, meant for anyone or anything that might someday find it. On that gold-plated disc are the sounds of wind and rain, of laughter and music, greetings in 55 languages, even the heartbeat of a young woman named Anne Druyan, recorded while she thought of love and life on Earth. Etched into the metal are instructions, a star map, and a phrase. To the makers of music, all worlds, all times. When Voyager went silent, many feared that record would never be heard. But when it spoke again, one NASA engineer whispered, "The record still sings." And maybe that's what makes Voyager one more than just a spacecraft. It's not simply a collection of metal, wires, and fuel. It's a message from us to the universe, a reminder that we exist, that we wonder, and that we reach for more. Even now, engineers continue to analyze the data Voyager sends, faint, flickering signals that travel billions of miles through interstellar dust. Some of the latest readings suggest small but distinct changes in electron density, as if Voyager is approaching a new kind of frontier. Perhaps the edge of the local interstellar cloud. It could be a coincidence. Or it could mean that Voyager has crossed into another region of the galaxy, one we've never charted before. NASA stays cautious, but among scientists, there's quiet excitement. Because if those readings are true, Voyager 1 might be revealing a completely new structure of our galactic neighborhood. One that changes how we understand the boundary between stars, and while debates continue, the probe keeps going. It doesn't rest, it doesn't slow down, it just moves, 1 second at a time, into the deep unknown. At its current speed, Voyager will take another 40,000 years to pass near another star system. By then, humanity will likely be gone or transformed beyond recognition. But that small spacecraft, carrying our story, will still be traveling. still listening, still speaking if someone, or something, out there knows how to hear. When the story of Voyager is told, it won't just be about distance or technology. It will be about determination, the refusal to surrender to silence. NASA's engineers didn't just repair an old probe. They reached across 15 billion miles of emptiness and pulled a piece of human history back from the void. They turned failure into faith, data into hope, and in doing so, they reminded the world that exploration isn't about knowing what's out there. It's about not giving up until we find out. Voyager 1 may one day fall silent forever, but even then it will keep flying, past stars, past galaxies, into eternity, carrying a golden record of who we were and what we dared to dream. Because Voyager's greatest achievement isn't distance, it's endurance. And as long as that faint signal reaches us from the edge of the stars, humanity will always know we are still listening. So here we are, nearly half a century after launch, and Voyager 1 is still talking. Against all logic, all odds, it defied death and reminded us that even silence in space can have meaning. Maybe what keeps this old probe alive isn't just its nuclear power, but the same human drive that built it, the refusal to stop exploring. And that raises a haunting question. What if Voyager's next signal isn't just data, but discovery, something that changes how we see our place in the cosmos forever? If you believe this story deserves to be heard, hit like, share your thoughts below, and subscribe to Galactic Breaking News for more real, mind-bending space updates. Because out there, beyond the sun's reach, Voyager's next whisper might just rewrite everything we thought we knew. Stay curious and stay tuned. On October 29th, 3I/ATLAS used the sun's gravity in a Voyager-like slingshot, a maneuver only spacecraft have ever done. Then, just 2 days later, it sped up by 287%. Shocking NASA and defying every known law of celestial motion. Was it a natural reaction to solar energy? Or something intelligently controlled? Every new data point makes the mystery deeper. Let's dive right in. When Dr. Avi Loeb spoke about 3I/ATLAS, few took him seriously. He wasn't predicting doom. He was asking a question that most scientists were afraid to say out loud. What if this thing isn't just drifting? What if it's doing something? NASA called it a comet. Cold, predictable, harmless. But Loeb noticed details that didn't fit. The path was too perfect. The alignment with planetary orbits too precise. It wasn't chaotic like space debris. It was deliberate, like a traveler who knows exactly where it's going. October 29th, perihelion, the moment 3I/ATLAS brushed closest to the sun. Loeb said that if the object were artificial, that's when it would act. The sun, after all, is the universe's biggest energy source, a perfect moment for any spacecraft to recharge, redirect, or reveal itself. At first, nothing seemed unusual. It glowed faintly. It moved steadily. NASA